What's up? 317. Here's your class notes for today, since we had half our class gone, celebrating the Cubs' victory on Friday. So we kind of had to split the class up. Today's lesson is pretty much review. If you took an Algebra 1 class, which all of you have, you should know what's up for this. There's just a couple new things. The first thing I want to talk about is graphing lines. There is a warm-up on your notes. I think you guys are all capable of doing that on your own without much instruction, but I just want to give you guys a reminder of graphing a line in slope-intercept form, which is y equals mx plus b. M is your slope, b is your y-intercept. You're going to plot that y-intercept. You're going to count out your slope, rise over run. The other form you might see is point-slope form, which is number 2 here that I wrote out, and that one maybe you didn't use as much in Algebra 1, but it's my favorite way to write a line, so you'll be seeing it a lot more in Algebra 2. Looking through those notes for today, it's not that prevalent, but you'll see it eventually, so keep that form in mind as well. I'm going to go through the first couple examples with you, talking more about linear inequalities. Linear inequalities, guys, just like graphing a line, but there's a greater than or less than, or greater than or equal to, less than or equal to sign, so it's a tiny bit different. There's going to be some shading, so we're going to get a little shady today. Let's go. Like my jokes. Okay, solid line. When do I have to graph a solid line?
When there's an inequality.
Nice try, Frosty. Close, though. When there's an inequality that has an underline. So it's when it's greater than or equal to or less than or equal to. And when do I have to graph a dotted line?
When there's no line.
When there's no underline. So it's just greater than or less than. Nice. All right, so that's for the kind of line we draw, but what about the shading? I shade above when?
It's greater than.
Yep, greater than or equal to or greater than. And I shade below? Less than or equal to? Yeah, less than. Oops. Yeah, just when it's less than or equal to or just less than. Nice. Okay. So, let's graph our first inequality. This should still be an Algebra 1 skill, but we're going to need to know how to do this pretty well for this lesson. So, number 1, we have y is greater than or equal to negative 2x plus 5. So, just like y equals mx plus b, I know this is in slope-intercept form because the y is by itself. My slope is negative 2. Let's write that as a fraction. So negative 2 over 1. My y-intercept is 0, 5. So we're going to plot that point right on the graph. There it is. All right, negative 2 means down 2. Positive 1 means right 1. So let's count it out. Down 2, right 1. Okay, draw a dot. Down 2, right 1. Down 2, right 1. I'm cool with like 4 points, and then you can draw your line. On Notability, it's really nice with the new update. Check it out. Drawing lines is fun. This is going to be a solid line because this inequality is underlined, so we're going to draw a nice straight line through our points. And now we have to shade. So shading this is a greater than, so I have to shade above the line. So I'm going to shade up here. There it is, guys. Let's do another one. This one's not in slope-intercept form for number 2, but we can easily move it there. So in order to move something in slope-intercept form, you just got to isolate y. You got to get it by itself. So let's subtract over 3x. If my Algebra 1 kids can do this, you guys sure as heck can as well. Oops.
Sure as heck.
Sure as heck. We got a less than sign here, so we have negative 3x plus 8. And divide out every single term by 2. So what do we got? We got y is less than negative 3 halves x plus 4, which means my y-intercept is 4. My slope is negative 3 halves. Y-intercept of a positive 4. Let's draw our point. And then we're going to go down 1, 2, 3, right 2. One more. Down 1, 2, 3, right 2. Nice. Now we have a less than sign. It's not underlined, guys, so we have to have a dashed line. Draw your arrows, and now let's shade. And this is less than, so we got a shade below. I'm hoping you guys get the idea. One thing to note, especially for something like number 3, it looks like y is by itself, but there's one little thing we got to change. That's a negative y, so I have to divide everything by -1. Just be careful, guys. When I divide by a negative, what happens to my inequality sign? The answer is that it switches.
Be careful out there, kids.
Careful, guys. 4/3 x minus 1. Okay. Let me write that again. Y is greater than 4/3 x minus 1. The reason that 4/3 became positive is because it was originally negative, divided by a negative, which becomes positive. My y-intercept's -1. My slope's positive 4/3. Let's graph that. This is going to be a dashed line again. And we're going to go up 1, 2, 3, 4. Right 1, 2, 3. If you listen carefully, you can hear a horse trotting down my street right now. That's not a joke. Those horse carriages that you see in Chicago goes right down my street. It's pretty cool.
Wow, you're cool.
Screw you. Okay, dashed line greater than. Here we go. There's the shading. All right. That is an Algebra 1 skill that I'm hoping you all remember pretty well. Now we're going to get into Algebra 2 stuff, which is graphing linear inequality systems, which means there's more than one equation. Things are about to get crazy. Let's go. Here we go. Just a couple examples here, guys. The only difference here is that we're graphing more than one line on the same graph. And the key here is that when we're graphing systems of inequalities, you have to shade shade the region. Shade the region that satisfies all of the inequalities. So I'll show you guys what I mean. I like to graph one line, shade it, graph the second line, shade it, and then really darken the overlap. Austin Scott has joined me to teach this lesson right now. I'm kind of nervous about what you're going to say. Let's go. So the first equation, I'm just going to circle it in red because I'll graph it in red. My slope, Austin, what's my slope here?
Whatever's before the x.
Yeah, which is 1 over 1.
The m, as they say.
Yeah. And then what's my y-intercept?
+2, +2.
No, you're looking at the wrong line.
Oh. -1.
Yeah.
My bad, guys. Sorry about that. I was looking at the
second one.
problem below.
It's the same problem. Okay. Okay, so we're going to plot -1, and we're going to go up 1, right 1, up 1, right 1. We're going to keep doing that. This is a dotted line, a dashed line. And it's greater than, so we're going to shade above. Now, I kind of like to just do, like, lines for this one because there's going to be multiple spots we shade, and I just like to really see which part is going to overlap. So then the second one, I'm going to circle this in blue. Oops, I'm going to circle that in blue because we're going to graph it in blue. My slope for this one is -3 over 5. When that negative's in front, I usually just put it with the top number.
They call that the rise over the run.
They sure do. My y-intercept is 0, 2. So there's 0, 2, and I'm going to go down 1, 2, 3, and right 1, 2, 3, 4, 5.
Or the change in x over the change in y.
Other way.
Or whatever. Doesn't really matter.
Yes, it does. It's kind of a big deal. All right, this is going to be a solid line. And this is less than. Now, here's the part that I want you guys to really see. Okay? This is being shaded less than, which means I got to shade below the line. I'm just going to do this with the green pen. And what I'm looking for, the final answer is actually going to be where the region where the two lines or the two shadings overlap. So I can't talk. So the shading overlaps in this region. So this is the region that you want to highlight, really. So usually when I do this like on paper, I just very lightly shade both regions, and then I with like really dark shade the part where they overlap. I think I've really overkilled this overlap, but that's the answer. It's where the two shadings overlap. Ta-da. All right, next one. And this stuff is
Why
just...
are you yelling? Just talk to the kids. You're screaming at them. Just talk to them.
I'm just naturally loud. This is great. Thanks for your opinion. All right. The next one. Now I feel like I can't talk loudly. That's my style. My jam. Guys, what kind of line is...
Oh, man, you got to change that into slope-intercept form.
This is a vertical line.
Oh, you're right. Slope is undefined.
Nice. Okay, so the slope is undefined. Basically, remember, when it's x equals or x is less than or greater than a number, that's when you have a vertical line. Okay, so that's how I knew this was vertical. And it's kind of nice. You just think of it like this. X is greater than or equal to 1. So on my x-axis, I'm going to put my dot on 1, and then you draw a line through that. This is going to be a solid line because it's underlined. Now, you have to think about it this way for the shading, because you can't go above or below a vertical line, but we're looking for values greater than this. So the values greater than this... Board. The values greater than this are over here.
I just don't think anybody's listening at this point.
Just kidding. You're good. Okay, guys, I just kicked Austin out of the room because he was annoying me. But we were looking for values greater than 1, which is going to be in this direction, which is why I shaded in red over there. Okay, so let's go on to graph the second line. We have y is greater than negative 1/3 x plus 2. So positive 2. We got negative 1/3. So down 1, right 1, 2, 3. Maybe one more. Down 1, right 2, 3. And this is going to be a dashed line. And for this one, I'm shading above. So the overlapped region is right here, in between these two lines, right in here. Okay, I think we're good. Sometimes you'll have 3 lines, so that's like number 3. All right, so for this line, this is a horizontal line. And so we go to our y-axis, we put a dot on 5, draw a dashed line right through that, and this shading is going to be below. I'm just going to do lines like that. Perfect. Next one, let's go with this guy. Now, this one is kind of fun. We got to get y by itself. So I have a negative 4y is less than 2x plus 8. Divide everything by negative 4, which means I have to flip the sign. So I'm going to have a negative 1/2 x and minus 2. Okay, because when I divide by 4, guys, 2 over 4 is 1/2. Got a negative. So this is the line that I need to graph. Negative 2 is my y-intercept, and I'm going to go down 1, right 2. Down 1, right 2. You can go up and left if you want. This is a dashed line again. Okay. And we are shading above now, because originally it was less than, but we had to flip the sign. So far it's pretty clear to see our shaded or overlapping region. But we still have one more line to graph. And so finally, my last line is this, y is less than or equal to x. So guys, for this line, the slope is 1, and the y-intercept, there is none, it's 0. So up 1, right 1, up 1, right 1, so on and so forth. We have a solid line, and it's less than. So my final answer, the shading where all 3 of these overlap, is right in here. Lovely. Well, this just looks like I gave a 5-year-old some crayons to color in the lines, but that's how you do these problems, guys. No big deal. I'll do the other 2 examples in class. I just wanted you guys to have a good idea of what was going on, so I'm going to leave you with that. Hope this was fun. You guys got to meet Austin briefly, and yeah, peace out.